Now the next step on our moving platform is we want to be able to give it as many waypoints as we want. You can think of floating platforms kind of like in Super Mario Bros. 3, where sometimes the entire level you're almost on a moving platform that goes between waypoints. So we want to get to something like that where we can build it anytime we want. First, before we can do that, you need to learn about something called arrays in programming. So this video, I'm just going to show you some basics of arrays, and then we're going to make an array for our platform. So to demonstrate this, I'm just going to create a quick sample script here. I'm just going to call this array test. Now I'm going to open it up here. And we're not actually going to do anything with this script. I'm just going to demonstrate how arrays work for you here. So all an array is a group of objects of the same type. So to be even more simple, take a group of any type of variable that we've used so far, and you could make an array of those. Let's do something like this. If I had int, and I'll just call this numbers, and then normally I would make it equal something like 5. So now I have a variable called numbers of type integer, and it has the value 5 in it. But if I wanted multiple numbers, I would have to do something like number 1. Copy this, and then number 2, we'll give it a different number. Number 3, this would be something else, and so on. So say if you had a bunch of tests that you were trying to get an average of or something like that, you would have to make a variable for every single number that you wanted to use. In programming, we don't want to be repetitive like that. We want to do it so we can automate it via code. So this is where arrays come in. So for something like this, instead of making multiple variables, let's say we want 5 different numbers. I'll just call this numbers again. What we can do instead of just integer, if we put square brackets in front of it, this is what's going to make an array. So it's still the normal integer, but these brackets are telling this variable named numbers that there's going to be multiple numbers inside of it. Now, when using arrays, we have to tell it how many values are going to be in there right from the start. So it's not something that we can change. If we set this to 5 now, we can't change that to be, say, 25 halfway through our game. We have to set it to something specific. Now, the way you do this is we assign a value like we would be putting a number into a normal variable, except here we put the word new, and then we put int with this opening square brackets again. So you might notice this looks a little familiar with how we made a vector 3 on our camera controller. So we did the position equals new vector 3, which is the type, and then we gave it the values. It's a similar concept to that, but not quite the same. So inside this square bracket, this is where we have to tell it how many we want. So if we put 5 here, notice the error goes away. And now we have 5 different numbers inside this variable. So now if we wanted to start using those, the way we do this is we use numbers, and then we put a square bracket after it. And inside here, you use what's called an index. So since we put 5 numbers in here, you got to remember with programming, we always start at 0. So what this does is it makes 5 different variables inside this array. So you can think of it like 5 separate integer variables. The way we access each one is putting a number in this box. So the first one starts at 0. So if we do something like numbers 0 equals 2, now we just assign 2 into that value. And then we could do something similar. We could do numbers 1, give this a value of 3, and so on. And then anytime we want to access them, it's the exact same way. So if we wanted to do something like, say we made an integer value called sum, and we wanted to add them up, we could do the exact same. Numbers 0 plus numbers 1. So the way we do math, the way we operate with them, it's the exact same. It's just we have multiple values inside of one variable. Okay, so that's the quick little primer to using arrays. There's a lot more to it than this, but at least this will give you how they work. And we're going to start using one in the next video where we add this to our moving platform. Now that you understand the basics of arrays, we can start incorporating them into our waypoint system here with our moving platform. So what this is going to allow us to do is add as many waypoints as we want, and the system's going to dynamically work with them. We won't have to change any code. So let's open our moving platform here. I'm just going to select the platform and open the script. So now we're going to refactor this code again, kind of like we did in the last video, and we're going to improve on it even further. Now this is also going to start to show you how much freedom you have with how you program. And what I mean by that is right now we have an if statement checking if we're moving to the target, and then an else if we're not. We're going to change this a bit because you can see right now we're using this transform.position equals vector3.move towards both times. We don't actually have to do that. We can do that once and then just do a check on which waypoint we're going to. So that's what we're going to do in this video. The concept's very similar, but you're going to learn a lot more about programming in this video as well. Okay, so the first thing, I don't actually need a target or start transform anymore. So I'm going to delete this line here. And now we're getting a bunch of errors down here. That's fine. What I need to do this time now is I need to actually create an array of transforms. So the type of variable I want is transform. And then remember, I need to put the open and close square brackets to make it an array. And I'm just going to call it waypoints. Okay, and remember before with variables, we could just do this and assign to them later. I showed you in the last video, we need to actually declare this and say how many waypoints we need. So in this case, we would have to do something like equals new transform, and then in the brackets, we put how many. So say in this case, we need 2. Now this creates me an array of waypoints with 2 variables in it. So 2 different transform variables inside of waypoints. So let's get this working with what we have set up right now with our start and end one. Now notice we're getting an error here because it doesn't know what start transform is anymore. We can actually just replace this with waypoints. And then in the square brackets, we need to tell it which one. So 0 is the first index available to us, which is the very first one inside of waypoints. So to move to the first one, we could just set it to waypoint 0.position. And now for this here, where we're looking at this check, so we need to check if the position's not already at the target, not target transform, but we need waypoints 0. And then if we're not at that one, we also want to put it here. So waypoints 0. Now for right now, I'm just going to delete this else statement. We don't actually even need that right now. So this is if we're moving back to the start one instead of the target. So I'm just going to delete that for right now so we don't have clutter. And if we look at this code, this should move us to our first position. So let's go back into our game. Now, if we look in the inspector here, we don't see our waypoints. Remember, we have to make serialized field in front of anything we want to see in the inspector. And since we need to assign these manually, we need to do that. Okay, so now you see we have this drop down for waypoints where it has a number 2 here. And if we click the drop down, this is how arrays are going to show up in the inspector. So we have 2 here. Now, something I want to show you before we carry on, we do have to tell our array how big it is at the start of our game. But if we're making it serialized or public, we don't have to do this part right in here in the code. We can actually do this in the inspector. So notice now that I remove that, if I come back to our script here, if I just click on the drop down and select reset, it's going to reset it back to how it would look as a brand new script. So waypoints by default is set to 0 and this list is empty. I can assign how many I want to it before we run our game. So I can type a 2 in this little box and now it makes my array of waypoints 2. If I wanted to make it 5, it'll do 5. So we can't change this once the game starts, but before we hit play, we can change this in the inspector. So let's go back to 2. Now I'm going to drag start position into 0 and target into element 1. So this is basically what we had before. And now if we run our game, we should see our platform move. And it's not. And this is actually a typo I made. If we go back to our code, so at the start, we're moving to the first position, which is waypoint 0. But then to move, we want to be moving to the second one, which is waypoint 1. So remember, because it starts at 0, we always have to subtract 1. So if we're moving to the second position, it's going to be 2 minus 1, which will be 1. Let's try this again. Okay, so now we're moving to the first position. If I change the speed to be a bit faster, notice we get there and then nothing happens. So now what we have to do is tell it how to check if we reach that first position. So we have the check here, and we're using this moving to target. What if we just simplify this a bit? So I'm going to cut this if statement out here where we move, and I'm going to delete everything else. And this is one of the powerful sides of programming. So if you're not familiar with programming before taking this course, we're only going to cover the basics in here. But as you learn more about programming, you're going to learn there's multiple ways to do anything. And that's kind of what I'm trying to show here with each of these refactors. You're going to learn a bit of a different approach you can take. And then from that, you develop your own style that you use. So let's do our first check. We're just going to move to this target position if we're not already at it. Since we're using move towards, we don't actually care if we're moving to the target or not, because we're always going to move to a target. So I'm just going to delete that variable. Now all we have is this. But what we have to do next is tell it what happens when it reaches that target. So let's do that here. We'll do reach the target. So now this is going to be our else statement. And what we have to do at this point is change which waypoint we're moving to. Now this is where you're going to see why having an index like this in an array is so much more powerful than having something like 10 different variables for each of our waypoints. Because we can change this value as a variable and make it change during the game's running. So let's make a new variable here. I'm just going to make an integer. And let's call this current waypoint. And by default, we'll set it to 0. So this is the current waypoint we need to move to. And what we should probably do and start here is we move our platform to waypoint 0, the very first one. So if we're already at 0, we're going to want to make our current waypoint 1. And if you remember previously, I showed you we could do current waypoint. Actually, we could do it multiple ways. We could do current waypoint equals current waypoint plus 1. So that's one way to do it. Or we could do current waypoint plus equals 1, which is going to take this variable and add 1 to it. Or we can just do the shortcut plus plus, which will add 1 to that value. So let's do that. Well, we'll make a comment here. We'll say set our current waypoint equal to second waypoint. So now if we reach the target, what we need to do is increase its waypoint to the next one. But the problem here is if we only have 2 waypoints, if we increase it, it's currently set at 1. If we increase it to 2, we don't have a 2 in our waypoints. So we need to know if we're at the last waypoint or not. And what I mean by that is if we go back to our game, notice here our waypoints, we set it to 2. So that means we have value 0 and value 1. If we try to access something in value 2, which would be down here, it doesn't exist. And that's going to cause an error that's going to stop your game. So in here, we need to actually do a check on that. We need to say if, and we got to say current waypoint. And now we need to know how to check if we're at the last one or not. So when you're working with arrays, our array is called waypoints. We can actually use something built in. So we want to check if our current waypoint is less then waypoints.length. And now let's talk about this for a second here. So waypoints.length is going to give the value of our full array. So if we look here, it's going to give us this number. How many elements are in here? So the value is 2 because there's element 0 and element 1. But we have to remember that it starts at 0. And this is pretty confusing at first. I remember this confused me a lot when I started. So we have element 0 and 1. If we look back at our code, if we say if current waypoint is less than waypoints.length, think of this right here as saying 2. But remember, our current waypoint is 1. So if we say less than 2, that's correct. And if we did that and we increased it one more to number 2, that value doesn't exist in here. So what we have to do is we have to say if it's less than waypoints.length minus 1. And this compensates for this starting at 0. Okay, so now if it's less than that, what we can do is current waypoint plus plus. Now our problem here is if it's not less than that. So say if we're at 1 and we only have 2 waypoints, that means we're at the last one. For now, let's just try, we'll set it to current waypoint minus minus to set it back 1. But in here, instead of having a hard-coded number 1, what we need to do is put in current waypoint. And then same with right here. So this way, anytime we change the value of current waypoint, that's what our platform is going to try to move to. So let's go test this out. Okay, so now we went back to the first one. Okay, so it's ping-ponging, and that's good. You might think this is fixed now, but remember, this is only part of the way, because if we add another waypoint, it's not going to work anymore at this point. So this is kind of the halfway mark of how we want this waypoint system to work. But since this video is getting pretty long and this is a lot of new concepts to take in, I'm just going to break here and we'll continue in the next video. Now in this video, we're going to carry on from the last one where we had our waypoint system working with 2 waypoints, but if we add more than 2, it's currently not going to work. So the way we have to fix this is we need to actually add a variable kind of like we had before, except this time we're going to call it isMovingForward. And I'm going to set this to be true by default. So now we're going to control if the waypoint system is going forward, and then when it reaches the end, we're going to tell it to switch to going backwards. None of this has to change at all. It doesn't matter if we're going forward or backwards, because all it's looking at is the waypoint that it should currently move to. It doesn't care which direction it's going. And that's why I like this approach better than what we had in the last video, because we don't need to tell it 2 different options. So all of our logic is going to fall right in here of once we reach the target. So what we have to do here is, instead of just doing these checks, we first have to check, are we moving forward or backwards? So we want to say if is moving forward. Now we want to check if the waypoint's less than the length. So let's add this in here. Now all of this code stays the same, but the difference is, let's think of this logic. So if we reach the target, it's going to run this code. We're going to check, are we moving forward? If true, then we do this check. Think of this one as checking if we're still not at the end of the last waypoint. So if that's true, let's just go to the next waypoint. But if it's false, that means we reached the end. So we're going to tell it to decrease 1 from the current waypoint we're going to, but that's not actually going to fix anything because we're going to keep moving to it. The next time this code runs, it's going to try to increase it again. And we're going to get stuck in a little loop. So what we have to do is we have to tell it is moving forward equals false, because we're now going backwards. And now to also correct that, we need to add an else statement down here. So think of this one, just to be clear here. So this is moving forward. And I'm going to put a comment here for this else statement, moving backwards. Just so you understand which is separate here. So what we have to do here is basically the same thing as up here, except we don't care about the length of our array. What we care about is we want to check if our current waypoint is less than or equal to 0. So we could actually just check if it's just equal to 0, but it's good practice to check just in case some bug hit and it went below 0. So now if this is true, this means if we're currently at waypoint 0, we need to turn around and start going forward. So then we want to change is moving forward to be equal to true. And we want to increase the waypoint. And then if we're not at the first waypoint, so waypoint 0, then we want to keep subtracting a waypoint. So let's go to the previous one again. Okay, so this is a lot more code than we've been used to so far, but this is basically the most basic waypoint system you can have in place. So if you're struggling with some of the logic here, feel free to add as many little comments as you need to make the code readable for yourself. No matter what, at the start, we're going to start moving. And then if we reach our current target, we do this code. If we're moving forward, we do this check. And if we're moving backwards, we do this. Okay, so let's make sure this all works. So what I'm going to do is I'm going to set my waypoints to 4. And instead of these names, we want to make sure they're always in the correct order. So I'm going to call start position waypoint 0. Target position, I'm going to call waypoint 1, and I'm going to move it below just so they're always in order. Now I'm going to select this one, hit Control D to duplicate it. I'll just rename it to waypoint 2. And now I'm going to move it, I'll move it say over here, and I'm going to duplicate it one more time. I'll call this waypoint 3. And I'm going to move this one up here. So if we have our platform set, we need to drag in waypoint 2 into element 2 and waypoint 3 into element 3. So now if we run our game, I'm going to set it to be 3 for the speed. Let's set it even a little faster. Okay, so we reached one, we moved, we go to the other one, we ping pong back. Okay, and now we're going through all of our waypoints. So with this system, you can add as many as you want, and it's going to go through all of them. The one thing I need to mention here, though, is we do have a bug where, say if we only had one point in our waypoint system here, notice we're going to get an error that we're out of range. This is what happens when you try to access something that doesn't exist in the array. So if we double click on that, what it's saying here is if we look and start, we're setting current waypoint ++, which sets it to the second waypoint. Then once we hit update, it's saying this doesn't exist, and it causes our game to crash. What we can do is a little bit of an error check here. So we can do an if statement, and we can say if waypoints.length is less than 2. And then in here, all we have to type is return with a semicolon. So what return is going to do is it's going to actually exit out of this update loop, and none of the code past here is going to run. So this is only going to run if we have less than 2 waypoints in our system. So if we have 0 or 1, this is just going to prevent all of this from breaking. So let's go try this out now. Okay, so you can see we have no error, but our platform's not moving because it doesn't have a waypoint. Okay, so now we have a simple waypoint system working for our platforms, and we could even use this code for any other object as well. I'll see you in the next video.